complexities of the growing unmanned aerial systems industry. Discussion points will be air traffic management, airport procedures, FAA regulations and commercial opportunities, as well as global infrastructure. Unmanned aircraft are currently becoming more popular in this day and age. It is the future of air travel, and the U.S. military as well as other countries are already using unmanned aircraft to help on their missions. This popular aircraft is also coming into civilian sector, where you can now purchase small drones from local stores like Walmart and Best Buy. Because of this, there has to become some set standards for the FAA for anyone who possesses an unmanned aircraft. Safety is the number one concern, and there has to be rules and regulations for everyone to adhere to. For this, we pose a question: what is the current status of unmanned aircraft systems traffic management, and when does the FAA expect a UTM to be complete? The FAA, NASA, other federal partner agencies, and industry are collaboratively exploring concepts of operation, data exchange requirements, and a supporting framework to enable multiple beyond visual line of sight UAS operations at low altitudes in airspace where FAA air traffic services are not provided. Unmanned Aircraft Systems Traffic Management, or UTM, is a traffic management ecosystem for uncontrolled operations that is separate but complementary to the FAA's air traffic management system. UTM development will ultimately identify services, roles and responsibilities, information architecture, data exchange protocols, software functions, infrastructure, and performing requirements for enable the management of low-altitude, uncontrolled UAS operations. A research transition team has been established between the FAA, NASA, and industry to coordinate the UTM initiative. Areas of focus include concept and use case development, data exchange and information architecture, communications and navigation, and ascents and avoid. Research and testing will identify airspace operation requirements to enable safe, visual, beyond visual line of sight UAS flights in low altitude airspace. NASA's Ames Research Center in California's Silicon Valley has set out to create a research platform that will help manage drones flying at low altitude along with other airspace users. Known as UAS traffic management, the goal is to create a system that can integrate drones safely and efficiently into air traffic that is already flying in low altitude airspace. That way, package delivery and fun flights won't interfere with helicopters, nearby airports, or even safety drones being flown by first responders helping to save lives. UTM research is broken down into 4 phases called TCLs, Technology Capability Levels, each with specific technical goals that help build up the system as the research progresses. TCL 1 was completed in August 2015 and served as the starting point of the platform. Researchers conducted field tests addressing how drones can be used in agriculture, firefighting, and infrastructure monitoring. The researchers also worked to incorporate different technologies to help with the flying of the drones safely, such as scheduling and geofencing, which is invisible flight zones assigned to each small aircraft. TCL-2 was completed in October 2016 and focused on monitoring the drones that are flown in sparsely populated areas where an operator can't actually see the drones they're flying. Researchers tested technologies for the on-the-fly adjustment of areas that drones can be flown in and clearing airspace due to the search and rescue or loss of communications with small aircraft. TCL-3 in progress during the spring of 2018, this level focuses on creating and testing technologies that will help keep drones safely spaced out and flying in their designated zones. The technology allows the UAS to detect and avoid other drones over moderately populated areas. TCL-4 was scheduled to begin in spring of 2019. The final level will build on the results and findings from TCL-3 while also working to test how the UTM system can integrate drones into even more populated urban areas. Examples of this include testing package delivery, infrastructure, inspection, aerial photography, news gathering, public safety, and first responder operations. After the research is completed, the results are compiled. NASA will then transfer the findings to the FAA for implementation. This partnership between research and regulation agencies, along with the input of thousands of experts and users, will set the stage for a future of well-connected sky. Drones will offer many benefits by performing jobs too dangerous, dirty, or dull for humans to do, and NASA is helping to navigate that future. Current regulations. The FAA is currently in acquisition for the first step of a UTM system, the Low Altitude Authorization and Notification Capability, which supports air traffic control authorization requirements for UAS operations conducted under the Special Rule of Model Aircraft and Small UAS Rule. The current airport notification and airspace authorization processes are manual for the small UAS. LAANC will provide Part 101 and 107 UAS operators a streamlined solution to enable real-time automated notification and authorization. Concurrently, the FAA and NASA have developed a joint UTM research plan to document research objectives and map out the development of UTM. NASA is conducting research at UAS test sites to further explore UTM capabilities that will accommodate rulemaking as it expands opportunities for UAS integration. The FAA expects that UTM capabilities will be implemented incrementally over the next several years. On October 5, 2018, the President signed the FAA Reauthorization Act of 2018. The Act establishes new conditions for recreational use of drones and immediately repeals the special rule for model aircraft. The agency is evaluating the impacts of this change in the law and how implementation will proceed. Currently, security restrictions limit drone operations near vessels operating from 2 naval bases in Washington and Georgia. Also, drone pilots have to get airspace authorization before they can start flying their drones in their area. These have to be approved from either the Low Altitude Authorization and Notification Capability or the FAA. The integration of small unmanned aerial systems into national airspace has been moving at a very fast pace to keep up with the rising number of small UAS in the airspace. These are being operated by hobbyists and commercial operators alike. One critical component of the operation of these aircraft is the safe separation from manned aircraft. To that end, the Federal Aviation Administration has mandated a requirement that UAS be operated within 5 miles of an airport must notify the airport and the air traffic control prior to the flight. Inevitably, UAS operators will be near an airport and helipad and must know the requirements for flight operations near these locations in order to safely operate near manned aircraft in transit to and from these locations. The FAA requires that UAS operations under a blanket COA must not be flown within 3 nautical miles from an airport without an operational tower or published instrument flight procedure. Any operations that would occur near an airport requiring notification would then be reviewed by the airport. The airport operator will review the operation that occurs within 5 miles. If such an event occurs, they conduct a detailed analysis of the request for safety and liability risks for that request. The decision to approve or disapprove the flight will be based on the nature of the flight, such as a Part 101 flight, Part 107 flight, or as public aircraft operation. Once that has been determined and all requirements have been met, the airport operator can approve the request. A study was conducted that monitored UAS operations in and around Dayton Beach International Airport. The study utilized a DJI aeroscope to detect UAS activity near the airport in Daytona Beach, Florida. The device was active for a 13-day period mounted to the top of a 3-story building. The device recorded data that recorded a census of unique UAS platforms, a number of individual UAS flights, operating locations, times, and maximum altitudes. During this time, the device detected 192 individual UAS flights with 73 separate DJI platforms. only 190 flights were used for the rest of the survey because 2 did not contain geological data. The study found that midweek was the most prevalent flying days, with Wednesday having 29 flights per day and Thursday having 21.5 flights per day. The vast majority of the flights, nearly 17.3%, occurred between the hours of 1900 and 2000 hours local time, with flights with a mean altitude of 238 feet above ground level. However, there were flights recorded up to 1,286 feet AGL. There were a total of 13 flights of great concern at altitudes greater than 400 feet AGL. 3 platforms were detected between 500 and 1,000 AGL, and 3 platforms were detected above 1,000 AGL. Of the 190 flights, 96.8% were detected within 5 statute miles of aerodomes. The vast majority of these flights were within acceptable limits based on the published facility map. However, there are a significant number of flights which were exceeding the limits. With that number being recorded in a 13-day time frame, it would be troubling to learn the actual numbers for a year. With that being said, airport operators and the UAS community will have to work together to ensure that each and every flight in operation are conducted as safely as possible. The future for UAS includes both vulnerabilities and resilience. Vulnerabilities include the First Amendment violations and liability. Resilience includes the overturning of the FAA's 6-year prohibition and limitless potential for commercial industry. The media, including the National Press Photographers Association, has addressed concerns that agencies such as the FAA can use force or seize drones prior to approval from a judge, and so have decided to take action to ensure oversight and due process is applied to this new media source. The National Press Photographers Association advocates for 3 changes on counter-UAS proposals. They include the inclusion of reasonable accommodations for news media which already exist for manned aircraft. The current proposals state DHS and DOJ shall avoid infringement of the privacy and civil liberties of the people of the United States and the freedom of the press consistent with federal law and the Constitution of the United States. However, there is no explicit requirement that DHS or DOJ provide reasonable accommodations for journalists to operate drones near covered facilities and assets. For manned aircraft, the Federal Aviation Administration allows accredited news representatives to operate in otherwise closed airspace if they coordinate in advance. Congress should provide similar First Amendment accommodations for accredited news representatives in any counter-UAS legislation. The second is to require the domestic counter-UAS framework to be established under the Administrative Procedures Act. The proposal states that DHS and DOJ may prescribe regulations and shall issue guidance to implement these counter-UAS capabilities, without requiring the DOJ and DHS to establish its counter-UAS framework and promulgate a definition of threat via notice and comment rulemaking. The public, including the news media, will be denied a forum to raise legitimate concerns and to provide constructive input on the creation of domestic counter-UAS policies. The third is to require public notice of covered assets. Under these proposals, DHS and DOJ are permitted to designate covered assets across the United States without an express requirement to provide notice to drone operators. For manned aircraft, the FAA promulgates a public temporary flight restriction to pilots before restricting airspace. Unlike facilities, which are likely fixed locations, assets could appear anywhere, could be mobile, and could be located near events covered by the news media on the ground and in the air, such as search and rescue, emergency response, disaster recovery, or fugitive apprehension. Without providing advance notice, a journalist reporting on a story of public concern that is designated as a covered asset, or entirely different news story in the vicinity of the covered asset, could be tracked and subject to lethal force against their news-gathering drone without notice that a covered asset had been so designated. A small victory for drone operators and potentially the commercial industry was the case between Rafael Perker and the FAA. Rafael was fined $10,000 for flying without a license while making a commercial for a university. When he took it to court, the judge ruled in his favor that no law prohibits the use of commercial drones. This, in effect, lifted the 6-year prohibition by the FAA on drones and opened the door for commercial industry. Drone operation is still fairly new to businesses, and they are looking to better assess their risk and craft insurance policies that will cover their future operation. To better navigate this new territory of liability, insurance companies are creating risk management plans, drone insurance policies, and standardized training to satisfy their new customers. With such clear resilience and industry looking to answer all the problems that UAS might face, it is clear that global integration is something that must now be addressed. In a 54-page publication, the ICAO addressed the new UAS need for global harmonization by setting forth 3 main goals. First, it would appraise states of the emerging ICAO perspective on the integration of UAS into non-segregated airspace and at aerodomes. Second, it would consider the fundamental differences from manned aviation that such integration will involve. Third, it would encourage states to help with the development of ICAO policy on UAS by providing information on their own experiences associated with these aircraft. The ICAO is also looking to establish an electronic system that would identify all drones in their use, position, trajectory, and altitude, as well as who owns them and the location of the person flying that remote aircraft. This would provide real-time information and would eventually create a database to be consulted by authorities in each country. Current ICAO recommendations are that all drones be kept at least 164 feet away from people and no more than 492 feet above the ground. They also suggest that a 5-mile no-drone buffer zone be around airports. The UAS industry faces many complexities, to include the integration of UTM and airports. However, through its resilience, it has managed to overcome many vulnerabilities and will continue to grow in its industry if it can successfully integrate on a global scale.